complex number, it is actually, you can do it this way. This is actually what we do here. Okay, I put it in formula. It looks like this, but you may you don't have to really memorize this formula, this properties number 5. As long as you do it, okay, you multiply both sides, numerator and also denominator, with the complex conjugate. With the complex conjugate, then you do the multiplication, okay, numerator and go. So this is a little bit of operation on that, involving complex number. So then this one. This might be a slightly abstract kind of question. So what we should do on this, okay, so we want to find the value of A. We want to find the value of A. So accordingly here, of course, it still use that the A should be a real numbers. Then this complex number is given as Z equal to -I. Okay, you just do accordingly. What you need to do is to get from the Z there, you need to go to find your Z power 2. So this is -I multiplied with -I. So here you have your, this with this, you have your I power 2, and the I power 2 is equal to -1. Then you go for your Z power 3. Or Z power 3, you can actually use the Z multiplied with Z power 2. Yeah, multiply with Z power 2. Of course, if you want to expand your -I, you multiply 3 times, you can. But I use this I result. Straight away multiplied with this -I, and I have the -1. So the answer for this here is I. Okay. Then you can have your PZ. This is a polynomial. So the PZ is given this one. So it is the Z power 3 minus Z power 2 plus Z plus 1 plus A. So we want to find the root of that one. So we replace Z power 3 with what we have here, I. Replace Z power 2 with this one, -1. Replace our Z with -I. Replace this, the rest we don't have to replace. And we want to find the root of a polynomial. When you go for the root, you know that it is just you equating this everything to 0. So I guess this example is merely for you to relate this with a polynomial, and our polynomial now is built with, is in terms of complex number. You can also solve it, okay? Some of the simple one, of course, you can solve it, but it is too complicated, you know, it's very difficult for you to solve that polynomial in complex number. Okay, hopefully it just open you, give you a different perspective that your polynomial can be in terms of complex number. Because so far we have our polynomial in real numbers, okay? So we extend it to complex number. That's it, okay? That's the purpose of this example. Then, of course, if you have that, okay, you can hear this and this, you cancel. Okay, it's so well that you cancel here. This is plus here, then automatically you can solve it, and you can find that this is actually -2. Okay, you get this answer, -2, because here it's 2, and then you just solve it. Okay, luckily we cancel this. Otherwise, your A, because here is already given its real number, but it is possible that A can be in the complex number. Okay, so that's the idea. Okay, I just repeat again. I just repeat this polynomial can be in terms of complex number. It's not necessary in real numbers. That's all this example search for. Is that okay? Any question? Those online okay lah, huh? Okay. Then this part. So as I say, this is all together later on. We are going to write our complex number. Not only in this form. Let's say you have a complex number. Okay, you have a complex number x plus I y. Okay? Of course, you can write your I at the back here, but I put it this way. Okay, it's the same thing because multiplication, you know that. So later on, this is what you call a plus bi form. This is a plus bi form. Is a normal form of complex number, but this complex number can be written in a different form. Okay, can be written in different form. The first one here we are using r and theta. Okay, so we have a polar form. You have another type of this here where you can write it as in terms of r and also theta. You give it in r and theta. Okay, so that is another form where we call this a polar form. Okay, so this is the first form. This is the second form. We call it a polar form. I think I don't have to explain much on this. After your multiple integral, you should know what's the meaning of polar here. Okay, so you have the parameter r and also theta. And again, you know that r is just something like your radius. Theta must be measured from the x positive, and going this direction will be a positive up to from 0 to pi over 2 to pi, go back to 3 pi over 2, go back to 2 pi. But if you go this direction, it will be from 0 to negative pi and so on, and negative pi over 2 and so on. This direction is negative, and this direction is positive. So that's the second form of the complex number. Then we have later on we have another form that you can write it. This polar form is actually for you to put it in the exponential form. Okay, it's for you to put it in the third one. This is called exponential form. The reason why we do this different form, of course, the polar form is simply the intermediate in between your standard form and also the exponential form. Okay, I can briefly give the reason why we need different form, because if you go for this form, okay, but if you do the multiplication and also especially if you do the division, you need to multiply with complex conjugate. Okay, numerator and also at the denominator. Okay, as I use this one, if you go for this division, you need to do this thing. Okay, but the exponential form later on, there is a way that you can do your multiplication or also division of your complex number much more easier. Okay, so that's the reason why we have different form of this. Okay, different form. Of course, different form it give you different information. Where this exponential form will give you the angle, we give you the radius, which is not given in this standard form. Okay, so that's why we need that. Okay, so then you have something very similar to your polar coordinate. Okay, a polar coordinate conversion formula, something very similar. So we have the x equal to r cos theta. I hope that you know why it is r cos theta, because of the trigonometry. Because of up to here is your x, from here up to here is your y. So when you use your what you call tangent, you can have your tangent is y over x, tangent theta y over x, or you can have your cos theta. This is actually from this cos theta is equal to x over r, and you have your sine theta is equal to y over r. Okay, so that's why you have this conversion formula, the same as in the polar coordinate. Then what you need to do is just substitute. This is very straightforward. You substitute into here, substitute into your y. Doesn't matter your I is in front or at the back here. Then what you see here, this is the common factor. You just set it up and you get this thing. Okay, so you get this thing. So this is the polar form. This is the polar form that we have. And R, of course, is the modulus. Okay, so you have this. So this R is known as modulus. It's simply the distance of the complex plane from object to origin. Okay, so then the theta here, the theta is known as the argument of Z. Okay, and the theta is not unique. Okay, why is say it is not unique? Because let's say if you find that your theta value is equal to pi over 4, make it very easy, pi over 4, then you can always have another value of this 2 pi. You can have another value of here which minus 2 pi, minus 2 pi. You can have different, okay? You can have different value of this theta. Pi over 4 minus 2 pi and so on. Of course, you have many. You can plus 2 pi, you can plus 4 pi and so on. So that's why the theta is not unique. Okay, the meaning of that, okay, is not unique. You can have different, but of course, the easiest one, if you choose any theta in between, negative 2 pi and pi, 2 pi, you choose in between that. Okay, so don't go beyond that. Okay, don't give something which is very big. Okay, some value which is very big. But you know that the idea of this is the theta will never be unique. Okay, as if you learn the trigonometry, you know that because it is something periodic. So it's repeating after 2 pi. The period is 2 pi and so on. So is that okay? So we have 3 different forms. So now our today the discussion is mainly for changing this one form to another. Okay. This is how we put that into here. Okay, into the exponential form. So the exponential form is very straightforward. You just go for this. This is the conjugate. If you find the conjugate, what you really need to do is to change the theta to negative theta. That's much you need to do. Okay. So we will come to here later on. So again, in final, you can't avoid doing this, changing from one form to another. Okay, the first one is very simple. I guess you have this kind of question here. When it is in the first quadrant, it shouldn't be a big problem on that. So what you need to do here is, of course, to come up with a diagram. Okay, you will come up with a diagram. This is real. This is imaginary. So this real tells you that it is 1. This imaginary also tells you that it is 1. So it is here 1. So this is the Z. This is your Z. You can have here, what you need to find is phi this R, what you need to find is phi this theta. So the first is, in first quadrant is easier, but this is in second or second, or other than first quadrant, you have to be very careful, slightly careful of that. Just wondering, is there any other lecturer that give you this convenient to either come physical class or online? Tak ada. Saya ada kan, saya yang memang baik hati kan. No, but this is a new trend, right? This, if you want to take an online course from Harvard University, you can. Okay? Okay, then back to this. You have go for this and this. Okay, this diagram is very important because, okay, so we get the error. So error is nothing but you take this A and B. This is your A value, this is your B value. So it is 1 power 2 plus 1 power 2, the square root. So you know that the answer is square root B, square root 2, sorry. Okay, then you obtain your theta. It's very straightforward because theta is actually y over x. So you have your inverse tangent. Inverse tangent, what is your y? Y is your 1. This is your 1 as well. So you can use your calculator, or you know that if you have 1, 1, this is square root. I shouldn't use this color so that it is not part of the solution that you need to show. Here it is this one, okay? This is 5 over 4, 1, 1 sub 2. 1, 1 sub 2. So if you have this, then you know that this 1, okay, this will give you 45 degree. This will give you 45. In other words, the theta here is 45 degree. Is that okay? You have this in your pre-university, right? Okay, so jangan diam-diam, but then you should treat this as a revision. Then what you need to do here, you have to put in your z. Okay, your z is initially is 1 plus 1i, or not to write the 1. Okay, you just write 1 plus I. Then this is equal to r. You may just put it if you need to refer this one, r cos theta plus I sin theta. Okay, so your r is 2, and this is you start with the cos theta. The cos is 5 over 4 plus I sine 5 over 4. So there is a reason why we put our I here. There is why mathematicians they put their I here. Simply because if you put the I here, then sooner or later you will thought that this I is belong to psi, which is not. Okay, which is not. So that's why we try to avoid putting our I here, but we put our I somewhere here. Is that okay? Do you agree with me? If we put I here, then for sure you know that the I will not belong to this side. So that's the idea. That's why we put the I before our side, our side trigonometry. So this is polar form. This is polar form. And you can write the exponential form, even simplest. You have this, then you go for the exponential. So exponential I, then this one you put the theta. The theta here again you put 5 over 4. Of course you can put 5 over 4 I. If you want to write it this way, you can. The same thing. No? I put it this way, the same. Okay, so this is known as exponential form. Exponential form. Okay, but one thing you may find in your any wet material saying that this is Euler form. Itu yang saya tak suka. Why I tak suka? Because in mathematics, if you Google, the Euler can mean many different things. You see here, there are so many things to do with this Euler. I guess it's a very famous mathematician. So if you have this Euler form, okay, where is that? This is, okay, sorry. This is Euler form. This one, not the exponential. The Euler form of apply here. And this is the alternative, or you call it a polar form, or you call it the Euler form. Okay, but as I told you that if you Google, the Euler can mean many different things. If you simply go for this, you have the Euler numbers, Euler circuits, and so on. This is what is these Euler numbers. Okay, so there are a lot. It's simply too many. E is also called a Euler numbers. Yeah, I'm not sure. Yeah, E. So Euler form of that. Is that okay? Yeah. And later on in your numerical method, you have the Euler formula again. It's simply too many. Okay, so this is the first example. We have the first quadrant, the pretty straightforward. Then the second formula, the second one is probably slightly challenging because they are not in the first quadrant anymore. So this one, number B. Any question on this side? Can I move to? Okay. Okay. So what we need to do here for this W, you need to again sketch the algebra diagram. This is your imaginary and this is real. You sketch this one because there is a mark for this. Okay. Usually I will give you here 1 mark and here 1 mark and here 1 mark. Then this everything correct is 1 mark. This is 1 mark. So 5 marks. Please. So here you can have your third tree. So third tree is a positive value because here we didn't emphasize here this is a positive value. Somewhere here we said that this is our third tree. Then you have your negative I, it is here. Negative 1i to be more exact. So this is negative I. So it is your W is somewhere here. Okay, your W is somewhere here. So now obviously this is your first this is your fourth quadrant. It is fourth quadrant. So you can have your theta conveniently this direction. Okay, I think I have to highlight by using other color because when you go for this direction, you should know that later on your theta is negative. It's negative value. You should go for this is negative theta value, or even though you find your theta value, but you put it as negative. Yeah, okay. So similarly, you find your error and so on. So error is given by this. Okay, error is this by this one. So sorry, here is pi sub 3. Then this is 1. This is negative 1 or 1. It's the same thing. So you go for this sub 3. Everything power 2, and then you have negative 1, everything power 2. Okay, so with that, you know that this is 3 plus 1, so this is 4 sub 2, it is just equal to 2. This is really like your theorem Pythagoras. Theorem Pythagoras, so you just find the length of this radius. Okay. So the theta, usually what I will do for the theta, I will not try to straight away find the negative theta, but I just limited myself to this quadrant number 4. So we are just using ignore the negative because we just take the length, which is this part y over x. So your y is 1. Okay, you don't have to put it as negative 1. Then here, then you have your this part is sub 3. Okay, I'm using this because we have standard triangle for us to evaluate this 1 over sub 3. you have this triangle, right? Here, if you say this is pi over 6, here should be pi over 3, right? Okay. So you have your 1, 2, and sub 3. Do you still remember this triangle? For you to get sine and cos for 30 degree and also 60 degree. This part, of course, is 30 degree. Pi over 6 is your 30 degree. And, sorry, 60, 30 degree, correct? And this pi over 3 is your 60 degree. So from here, we want to use this 1 because, no, macam salah ni. Hello. What is that one? 1, 2, subtract. Ini kan? Ini. Oh. Mana saja lupa. What is that called? What is that? Triangle for? It's for triangle angle. Is this one? Image. Oh, no. Betul lah, I'm not sure which one. What do you call this? Degree. Mana ni? Ini kan? Ini. Semua boleh Google. So you have your, this is 1, this is 2. Betul lah? Betul lah? Because dia terbalik kan? Betul. 1, 2, this one? Betul lah? So, whenever you have this over this, terbalik. Nanti. 1, 2 for 60, yeah? 1, 2 for 60, so it should be terbalik, huh? Macam ni. Pi over 3, pi over 6. Macam ni betul-betul. So whenever you have this over this one, so it is pi over 6. This is pi over 6. You may use your calculator, okay, for you may use your calculator and then set it in radian, and probably you get some ideas on this. So here we have this. Okay, you have this 5 over 6 here. Then, yeah, once you have this, you know that this is negative. So you should have your negative tangents given as this negative 5 over 6. Okay? So with this a lot, you can put your W where it is 3 minus I. Then you can put it as this R. What is your R2? And you have the cos 5 over 6 plus I sine negative 5 over 6. Or you can put it there. Or you can put it in exponential form, 2 exponential I negative 5 over 6. Or you can put it the same thing. The same thing. Of course, if you do not like this negative, okay, you can also say your W is equal to 2 cos 11 pi over 6. plus I 11 sine pi 11 sine 11 pi over 6. You can also put it this way. So how we get this 11 pi over 6 is basically, if you know that this direction we give you, ignore the negative. If you know that this give you pi over 6, right? This alone give you pi over 6. So from here up to here, it should be 2 pi minus pi over 6. So what you should do here, you equating the denominator. This will become 12. Okay, so you 12 pi minus pi, you get 11 pi. 11 pi over 6. It's just equivalent. Is it okay? So if you don't like to use this negative pi over 6, if you want to give your answer in 11 pi over 6, it's also equivalent. It's also equivalent. So that's why I said it is not unique. The word not unique, hopefully it makes sense to you. You have 11 pi over 6. Is that okay? So any question? You may try question number C now. I give you some time. Meanwhile, we have a 5-minute break. Okay, if you. Oh yeah. Do I still need to show QR attendance? Ada siapa yang belum lagi sign? Let me finish. Let you finish this first. Give you 30 seconds. And at the same time, you can try question number C. And we will have a break for 5 minutes. So question number C is negative 1i sub 3. Yeah? Any of you are here? 3 of you. Boleh. Saya tengah alamak. Itu attended. Pada just kira macam 17 saja di sini. Sedikit majority lah, apa you call? Minor majority. But that is your choice, right? I have to. Okay, I think for this type of question, what you need to be aware is the theta. Error shouldn't be a problem. Error is very straightforward. And you notice that, of course, the question are well designed. You can get the theta by using either this triangle or either this one. Okay, the question are designed so that's why you always see the sub tree appear, okay, in this type of question. Of course, it can be other than that where the theta is not that in a very convenient form, where you can put it in your decimal numbers, use your calculator to find your theta value in radian. Okay. Saya dah letak 25 nama saya sejuk lagi ya. Sejuk kan? Okay. Then we have here this question. Again, what you need to do, always start with the diagram. So each of the patient, you always have to start with the diagram, real and imaginary. Because this diagram will show you that in which quadrant that this complex number is. So -1 is somewhere here, and you have your positive sub-tree. You have your positive sub-tree. So this part. And then this is your jack. This is especially in second quadrant and in the third quadrant, you have to be very, very careful. Okay, you have to be very, very careful. Why you have to be very careful? Because if it is in this quadrant, okay, if it is in this second or the third quadrant, the theta is actually refer to this. Theta is actually refer to that one. Okay, I highlight using red color. Hopefully you use your red color as well, because when it is in second quadrant or it is in third quadrant, you have to be careful on this. And what you can find by using your by using your trigonometry is this part where you simply call it alpha. Of course, you can use any alphabet you like. Okay, so what we can do here later on from our triangle, of course, if you want to get this alpha, you can. Or you can also get this if you want. Okay, but here I get this part. If you want to say your alpha is here, then you can. But that one later on, I show to you. So, but R is still the same thing. R is this -1 and then plus this sub 3. Okay, power 2, then you have the square root. So here again, you have 4 sub 2, you have 2 again. That's sub 4, you have 2 again. Okay, then we have this R. After we have this R, we get this. Now we cannot get the theta directly. You get the alpha first. Where your alpha is simply your inverse tangent y over x. Y over x. So your y here is this part, which is your sub 3. And then I'm using 1. I don't have to consider -1 because this, after all, it is just in any degree in between 0 and 90 degrees. I use 1. I don't have to consider negative at all here. I think very similar to this, I did not consider the negative, okay, where I get any angle less than 90 degrees. Okay. So with that, your search here, it is, if you use this, it is tangent. This is this over this one. So obviously you know it is pi over 3. This over this. So this will give you pi over 3. Okay. So when this gives you pi over 3, your theta value now, okay, your theta value now should be, so how you get your theta value? It should be pi minus pi over 3. Because here, from here up to here is 180 degrees. So once you know that this is, how many? This is 60 degrees, you should know that here will give you 120 degrees, or 2 over 3 pi. So this is the extra work that you need to do whenever it is in the second quadrant or in third quadrant. So you have 2 over 3 pi. Yeah, correct, 2 over 3. So if you have that, then you know that your Z is just simply your R and cos 2 pi plus I sine 2 over 3 pi. And also here, you can also put it into exponential I 2 over 3 pi. Let's say just now you do not want to put your alpha here. Let's say just now you put your alpha here. Let's say this is alternative. If you put your alpha sub3 and here is -1. If you say your alpha is this, okay, you say your now I use beta so that it is not the same. If you go and find this, you can, because it is the same thing. Here you have your beta. This and this, the length is sub3. Then you have your sub3 and you have this is your 1, because this here is your 1. Then you can find your beta value by using this as well, where you have this over this, so your beta value is 5/6. 5/6. Then once you have that beta value, you know that this is 5/2. Then your theta will become 5/6 plus 5/2. 5/2. So how to do that? It is just 5/6 plus 3 5/6. You have 4/6 pi. It is just equal to 2/3 pi. Is it okay? So the same thing. Whether you want to put it this way, you go for this, or you go for this. Okay? The only thing you have to be very careful on determining this one. Determine this and this one. Is it okay? So any question? So hopefully you can score well in this conversion formula. Conversion question. Just convert your complex number from one form to another. And the reason why we do this conversion again is to help us to get to do the operation, either multiplication or either this division faster. Any question on this conversion? If no, I move on to the next one. The girl over there is more interested to check or to look at the guys beside her rather than my lectures. Yeah, sorry for disturbing. We go on this and then I go for this. Okay, so now this is slightly challenging question, as you can see. What is the challenging part? Because of course the first one, of course these are all the complex number. These are all complex number. You may say that this is your Z, this is your Z, this is your Z. Okay, these are all complex number. So the first one we have Z equal to 3 plus 4i. So why this is more challenging? Because we didn't see any sub-3. In many cases we have the sub-3 because of the triangle formula for 60 and 30 degrees. So again, the same thing here. What you need to do is to sketch the real and also imaginary. So you have your 3 and 4. So 3 and 4 here, this is your Z. You need to find your R and also your theta. Okay, straightforward, your R can be 3 power 2 plus 4 power 2. And you know it is 25 thirds, so it is 5. It's again convenient. You have the 3, 4, you have 25. Then theta, this is quadrant 1. So straightforward that you can use inverse tangent. This over this, which is 4/3. 4/3. Of course, now this 4/3 is not up here in. You didn't see any 4 and 3 in this triangle, you only see sub 2, you only see sub 3 and also 2 and so on. You didn't see 4 and 3. So that's why, of course, you can use your calculator to get the decimal numbers. What is the decimal numbers of this one? Okay, you can use that. Okay? Or you may just put it this way. Straight away using saying that this is your theta. So your Z in this case will be your phi. Okay, then you have everything is your cos. By that you have to put your theta, but now your theta everything is inverse tangent 4/3. Okay, inverse tangent 4/3 plus this I. Then you have your sine, and this everything is inverse tangent 4/3. This one. Okay? Or you can, of course, you can find the decimal numbers of this, okay, if you want, using your calculator. And question number B and C, you can see here, this is purely imaginary part. This is purely real part. You don't have the imaginary. So it is best for you to write this form as your B as 0 plus 6i. You put it in the standard form. Okay. Then if it is 0 plus 6i, the diagram will look like this. This is your real, imaginary. 0 is here, so this is your 6. It is this one. Okay. So if it is this one, then automatically you know the error. You don't have to do any calculation. Your error is equal to 6. You don't. This is the radius. Error is radius. You don't have to calculate. And your theta is also very straightforward. This is your theta, and you know your theta is 5/2 without doing any calculation. Of course, you can use you can go for this as well, or you can go for 0/2 plus 6/2 and so on. But it will give you 6 as well. If you can go for your tangent, but your tangent will give you infinity, I guess, or you can't evaluate really, okay, your tangent. You can't really get your tangent, but you know that on the diagram itself, you know that it is 5/2. Okay, so without using any calculation, with a diagram, you can write your 6i as 6 cos 5/2 plus I sine 5/2. You can put it this way. Is it okay? And we can easily evaluate the left-hand side is equal to right-hand side. If you go and find, if you say that this is your 0, this value is 1, right? So you know that this is the right-hand side, give you 6i, which is correct, exactly tally with this left-hand side, 6i. So this is a question with a purely imaginary part. You don't have the real part. Real part is 0. So no calculation needed. From the diagram, you can determine R is 6, and you know that theta is 5/2. Okay, the same goes to this question number C, where you have the real part only. If I say my C is Z equal to, of course you can let any others, this X. So X I can put here as X0I, okay, X0I. If you draw the diagram, real and imaginary. So the X here, simply tell you here, this is the X0. So let's say it is here. This is this one. So this is your J. So from the diagram already, you know that the error is X as well. Okay. And the theta is 0. Theta is 0 because it's here. Okay. This theta is starting from this X positive, going this way or this way. So with that, then you can write your F equal to X cos 0 plus I sine 0. You can put it this form. So in other words, any real numbers, you can put it in you can put it in complex form, A plus BI. Then you can put it in the polar form and also exponential form accordingly. And again, if you go for evaluating this, you know that this is 1, you know that this is 0, but in fact, you don't have to evaluate this, so just to show you the idea. So you get back your right hand side is also equal to that. Any question? So when the complex number becomes simplest, okay, as long as you really understand how it works, then you should write it in the correct form of this either polar or exponential. You may wonder the application of this complex number in computer science. It is no, nothing much here. But I guess it is this. I hope I spell correctly. So how do complex number? You see here, of course, you can go for the beauty of complex numbers. So it is complex number can be used to this is fractal, so generated by complex number. If I know this, it's correct. So it used in generating this one to study. It's a part of geometry. Okay, if you are interested in doing this, okay, this is a very pure computer science problem. Okay, but of course it's difficult. Okay, at this level, for our understanding to really to get this diagram. But then it's just to give you an idea. The application, right? There is a gap. Okay, no doubt there is a gap between our course and also how to really apply this. I have to admit. Okay, so back to here. So now. The reason why we go for this, I think this is to show. This is show that and it probably is slightly difficult for me to. Let me. Okay, yeah. This is actually a proving for the formula. For formula that if we have a complex number, if we put it in exponential form, if we put it in exponential form, then we can use this formula to get the multiplication directly and also to do the division directly by using this formula. Okay, I'm not sure whether I should show the formula first. This is the calculation, but I think we start by proving. We start by proving the why this is correct. We start by proving. The first one, we have the Z1. Okay, we have the Z1 multiplier. This is actually being multiplied, Z2. Okay, so this is our Z1. This is our, which is this one, given by this. Which is given by this. So here, because you know that our Z1 can be written as R1, you may just draw that accordingly. Then you have your cos theta 1 plus I sin theta 1. Then multiplied with your Z2, which is R2, cos theta 2 plus I sin theta 2. So indeed, in this step of calculation, what we do is nothing but to replace whatever Z you see with this one, and whatever Z2 you see with this one. That's the thing we do at this step, the first proving step. And we use polar form to prove the exponential form. Okay, so you know that polar form and exponential form, they are equivalent. So when you have this line, so what you can do here is you collect this with this. Okay, you put it together. Okay, you collect this with this. You have the R1, R2. Now you see this one. Okay, so what's remain here? Okay, what's remain here? You can expand it accordingly. So how to expand it? This multiply. Sorry. To expand that, you multiply this with this, multiply this with this, multiply this with this, and multiply this with this. This is what all you need to do. Okay, so you multiply accordingly. So I'm going to put a big bracket. This with this, I have cos theta 1, cos theta 2. This with this, I have my I. Then I have my cos theta 1, sin theta 2. This with this, I have my I, sin theta 1, cos theta 2. And this with this, I have I power 2, sin theta 1, sin theta 2. Hopefully you can expand this. You just expand this. Then I give you 30 seconds to see whether you can really understand this or not. Expansion involving polar form. Is it okay? Okay. So once you have this line, okay, you should know that this is equal to -1, and here, okay, here you have a I and I that you should factor out later on. Okay, so if I combine this, the first one, and I also have at the same time I collect these two. I put it because it does not have the imaginary complex number already. So that's why I collect these two and putting this as cos theta, cos this one minus sine theta 1, sine theta 2. Then this part here, I have my I. This everything, I have my cos theta 1, sine theta 2, plus sine theta 1, cos theta 2. I have this. So to simplify this, what you need to do is to use the trigonometry identity involving two angles. So later on we may go for we Google and then you can get the idea how to do this. But this is simply AB. If you replace A theta with A and theta 1 with A and theta 2 with B, then you can easily get the idea. Is it okay? So you may Google that trigonometry formula. So what are the formula that we are going to use? What is the easiest way? Where is your A and B, A and B, A and B, B? This one, too small for you to see. Where is the bigger one? And this is big enough. This part, the two different angles, this thing. So the first one that I'm going to use here is this. The first one that I'm going to use is cos A cos B minus sin A sin B. So we are going to use this cos A cos B minus sin A sin B. So if you are using this one, if you put it as minus, you can put it as plus. So these two can be reduced. These two can be reduced as cos theta 1 plus theta 2. Because of here, we are actually using this one, the second formula. So if you really want to write down the formula that we use, is actually cos A plus B equal to cos A cos B. It's actually plus minus. Then this is minus plus sin A sin B. We are using this for the first one. Then the second one is very straightforward. We use this. We use the first one, sin A cos B. So the second one, we are actually using this sin A plus minus B is equal to sin A cos B plus minus cos A sin B. The same thing, you have your cos A, you have this is your B, then you have your A and B. So it's the same thing here. You can put it this way to sin theta 1 plus theta 2. all you need to do is do expanded, then you use your trigonometry identity to simplify that. Okay. So with that, you can have your form as simple as this now, where it is cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. And this form, you can put it as a polar form, exponential form, as exponential I theta 1 plus theta 2 by using the Euler formula. Okay. So what do we mean by this? If you have a two complex number, if you want to find the multiplication of them, it is simply to multiply their modulus, and also you add their argument, which is your theta. Provided, of course, your Z1 and Z2, you have to convert it into either polar form or exponential form. So that's the meaning. Okay, so that's why I say a conversion from the standard complex number to polar form, and also exponential form is actually helping to do multiplication and also division. Is it okay? Don't worry, this is for demonstration only. You get what I mean? Huh? This is for demonstration, meaning to say that your writing is terrible. Later on in your exam 1 and 2, susah saya nak nampak. So, janganlah. Jangan. Then this part. Janganlah saya cakap jangan demonstration, you do like this. Saling pun tak nak. Okay, then the next one. The next one is to division. Division is slightly difficult for me to really explain this. Okay, we are not going this way. We straight away use what we have here. The B is to write down your Z1 and Z2. Okay, so nothing much that I say if the Z1 is already in real number, is already in exponential form. It is this one. Is your Z2 is already in this form. Okay, so we are not proving from the polar coordinate. It's difficult to do the proving. Okay, so what we have here, this form you can always read as R1 exponential I theta 1, and then multiply with 1 over R2, because this is R1 is divided by R2 is basically multiplied 1 with 1 over R2. And this part, initially it is power 1, but when you put this in the numerator, it will become, okay, so it will become negative 1. Is it okay? Because when you bring this power into here, it will become negative. So you have this. So if you make use of this, we can arrive at this R1 theta 1 minus theta 2 easily, because this part here you have R1 divided by R2, okay, and this one you have I theta 1. This one is in fact, okay, the multiplied with exponential negative I theta 2. Now still remember, if I have the exponential 2, I get this negative 1 is just the same as exponential negative 2. Okay, so that's the meaning. Okay, so if you have this already, you can use the index, right? Because index, this is multiplied, it's actually plus. So you have R1, R2, exponential I, theta 1 minus theta 2. Theta 1 minus theta 2. So in other words, if we have the division, if we want to do the division for two complex numbers, okay, we can go for their exponential form. After we have both exponential form, what you need to do is just divide your what you call this modulus R1 with R2, and you use the theta 1 minus theta 2. That's all you need to do. Again, it will simplify your operation, okay, involving division or multiplication of two complex numbers. I'm going to stop here because I think time is not enough for me to go through this. Okay, it requires at least 1 hour to go over this application. Okay, I'm going to stop here, and we see you again. Hopefully, there is still a sufficient number of you come to physical class. Otherwise,